is running in a machine. Software sitting on a disk does not have value. So we need to think of it as being a service. Now it's okay. I see Nakano-san thinking very carefully in the back there. Is a house a product or a service? The answer will astonish you. We will get to the answer very shortly. So we're looking at this behavior. We break it down into use cases. These are the complicated systems. In very simple systems, we have event-based systems, like change the color of this circle. I have a graphics editing program, and there's one event, which is change the color. That's a very simple kind of architecture. Let's say I have a text editor, and I have a use case, which is spell check. Spell check cannot be a method on some object. It's a lot of methods of many objects working together. And so it is a use case. Well, what do your professors tell you about how to handle a use case in an architecture like that? Where can I go in my architecture to find spell check? Uh-oh. So we have a problem here. And that's the problem that the DCI architecture was designed to solve. We break these use cases down into things called habits. These are a little bit lower level, and those get broken down into algorithms. So these are actually code that we write. The code that we write will be code for things called roles, not objects, not classes. So in the DCI architecture, we have a brand new concept. For the domain analysis, we have our good old friends, the classes. So I gave a talk on this last night. A use case might be transfer money from one account to another. And if I ask you, what does it mean to transfer money from one account to another, you might say, well, I will withdraw the money from a source account and deposit the money in a destination account. And that's a nice generic description of what it means to transfer money. And that is how you will think of it. And that is probably how you will express it in Japanese if I were to ask you. Well, what is source account? Is source account an object? Is it a class? No. What is it? It is a role. And this is something that has been missing from object orientation for 40 years. And in fact, it is the essence of what responsibility-driven design or what object-oriented programming is. So this process is going to lead us to a product that does the right things. Well, what do I mean, does the right things? There's first of all the simple part, which is the domain analysis part. And you probably all know something about domain analysis or domain-driven design. This is the kind of stuff that's in Eric Evans' book. This is looking at the long history of the discipline and understanding what are the things we are building. And so, what are the values here? Well, we value experience. We go to the domain experts, the people who are experts in our domain. How do you know a domain expert? Well, they usually have gray hair. They have been around for many years. How many people here are in telephony? You do telecommunications. Any telecommunications people here? I mean, a naive thing you might think of in a telephone system architecture is that, well, phone call must be an object, right? Well, if I'm making a phone call from here to Nagasaki, where is the phone call object? Is it here or is it in Nagasaki? I don't think phone call is an object, right? There's something missing here, and there has been for many years in classic object-oriented programming. And so we need to know that that is not how you do a telecommunications architecture. Instead, you have something called a half call. This notion of a half call is geometry. I can draw a picture of it in my head. And most of you, when you write software, if I ask you to close your eyes, you can make a picture of your software in your head. And so we think of these things geometrically the same way that Alexander thought of his creations geometrically. And last, we talk a lot about using a cross-functional team for the same reason we talk about this in Scrum, or that we have it in Lean. Now, if you are doing domain analysis and you have simple objects like a shapes editor, something like PowerPoint, where you want to say, change the font of this text, or change the color of this circle, you have what's called an atomic event architecture. The operations that the end user performs are very simple. Change the color of this, change the font of this, move this. Those are methods on an object. But if I have this DCI architecture, the operations are much more complicated. There are things like spell check this document. And that is not an operation on document because it involves the document, a dictionary, an end user, some menus that come up. Okay? It's what Grady Booch used to call a mechanism. And the object-oriented design you learned in university does not really have a place for that concept. The reason this is important is that the original goal of object-oriented programming is to capture the end-user mental model in the code. Well, if the end user has a mental model of a financial transfer or of spell checking as an algorithm, I should be able to find that in the code. That's the principle. But we have these two kinds of architectures. This is what we've been trying to do for the past 40 years. And what we will do is we will have something like spell checking, which is a relatively complicated operation, and we will split it up into many, 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 many small methods that go all over the place in our software. And now we cannot understand the software anymore because we cannot find the one place where the spell check algorithm is. And so we've made up for it with something called testing. And we try to test quality into a product. In the old days, I used to program in Fortran. I'm older than I look. And if I wrote a program, I could give you my program and give you the requirements. And here's a big red pen, and could you please check whether this program implements those requirements? And you could do that. Because the code implements the requirements. Today, I cannot give you an object-oriented programming and ask you, does it meet the requirements? Can you read this code and see if it meets the requirements? And the reason is we do not have a home for those kinds of sequences. And so we've tried to make up for it in testing, and software quality has gone down. Object orientation took away my ability to do that. What we're trying to do in object orientation, in object-oriented design, is capture the end user's mental model in the code. So if you have a concept in your head of your savings account, there should be a savings account thing in the code. If you have a concept in your head of spell checking in an editor, there should be a concept of spell checking in the code. That's called the user model. We want to put that into the code, and now the code should show itself on the screen. And so if I have this program running here, I want to see that code on the screen, because what I want to do is reach in and manipulate that object. That object is an extension of my memory. How many of you have heard of the Dynabook from Alan Kay? So Alan Kay says that when you are born as a baby, you should be issued a computer. It's called a Dynabook. And its memory is an extension of your mind. And its processing power is an extension of your brain. And this computer stays with you for your whole life. And yet you get technology upgrades for free to grow the memory and upgrade to technology. But the idea here has been one of the most radical